on to our next phase. David's going to talk a little bit about solar PV today, and then we're going on a field trip. So I'm going to go and get the vans ready, and we'll meet you guys down there.
Vocabulary, and talk about some of the concepts, and later on we'll see how they get implemented. We're going to get you started with the idea of available insolation, and that's not a misspelling. That's insolation refers to available solar energy or available sunlight. And a way to think about it is that outside the atmosphere, where there's no interference with the radiational energy from the sun, there's said to be about 1,368 watts per square meter. That's this. So that's outside the atmosphere, out in space, unfettered, uninterfered with sunlight, and that amount of energy is referred to as the solar constant. So part of what I'm trying to get across is that there's this constant amount of sunlight, but there's all sorts of things close to the surface of the Earth that vary the amount of energy that's available to us, the amount of insolation that's available to us. Okay? And so finally, these aren't hard and fast numbers, but generally, midday, clear day insolation, so best possible conditions, I suppose, might be about 1,000 watts per square meter. The solar energy that's available for us to harvest at the surface of the Earth on a momentary basis is said to be about 12,000 times greater than what we're actually, what we need. Yep.
So that statistic would be that if every single surface of the Earth was covered in a solar receptor?
Well, not every single
every
surface,
land
but
mass
if you had enough, in theory, hypothetically, if we had enough solar energy installations to harvest the amount of sunlight, we could easily supplant the need for combustion fuel, for carbon-based fuel. That's wildly hypothetical.
So given these numbers, you can assume that if we cover 1/12,000th of the planet in solar PV, we can support human life, theoretically.
Maybe. Think about that. It's a good question. But part of what appealed to me about this slide and these statistics was that there's a lot of potential in renewable energy, and a lot of potential particularly in solar renewable energy. There are other types of renewable energy.
You have to look at long term. You have no cost of input. So the system itself, like our current system, has to burn some type of fuel that you pay basically by the BTU. Solar, wind, all that negates that. So you basically have free fuel for an output.
Yeah, all right. So free fuel is a huge benefit.
When you burn, or like when we burn fossil fuels, it gives out harmful gases. Just like that, doesn't have any harmful effects.
Right. What's the carbon dioxide output of a solar photovoltaic panel? Right?
Well, nothing when you're gathering electricity, but the production of it.
Right.
Yeah. Right. So now you've got
Right.
something to put in the downside column. I mean, there still is the energy required to manufacture those leads.
Plus, are they like, are any part of them like recyclable? Because I know after like a couple of years they have to be replaced.
Well, for you, California has a requirement that the solar cells have to be recycled because they were worried that they'd go into the landfill because some of the properties that make the cell are mildly toxic.
Right.
So they do like I think it's 70% of the solar panel they can recycle and reuse.
Yeah.
Like the aluminum casings, all the
Right.
stuff on the back get reused.
Right. The glass, I'm sure.
Glass does, but the cell itself, they crush them up. Remember when we were in that class, I brought that one in from eBay?
Yeah. Uh-huh.
That was just a recycled cell.
Really?
The power plants don't have to work as hard in the middle of the summer when everyone's trying to use their air conditioning. That's how they're trying to sell it in our town and the surrounding towns, by using farmland to put solar panels on. Is, hey, look, our plants don't have to work as hard, we won't have to burn as much fuel, and we won't have to, and the consumers won't have to pay for the replacement costs of all of the machinery as it breaks.
So here's what's coming up.
We're almost
The first 2 weeks, the first 7 days of class are going to be here. And we are we're looking at well, clean energy issues. And then in the subsequent weeks of the class, we're going to look at how they apply to agricultural implementation in particular, although we'll do a little bit of that in these 2 weeks. So we have some trips planned to a wind turbine, to a PV array. We're going to get up to Barstow's Farm in South Hadley